Hey, hi Madhavi. Good evening. Hello Madhavi. Good evening. Hey, hi Kalpana. Hi Madhavi.
Hi Shiva, good morning.
Hey, good evening. Yeah, yep. So, okay. Yeah. Let me see. Oh, not this one. Eclipse ID. Okay. Yeah. So I think people are slowly joining. Let me get started then. Yeah. So people had some confusions around the traits yesterday. So let me recap that same thing. Just summarize it instead of too many confusions there around that. Yeah, let me make it simple for now. Okay. So I'm keeping you on mute, everyone. So trait, in simple terms, I have to convey. If you are aware of Java interfaces, it's very, very, very similar to it in functionality. The only one difference that you see, so some of the methods that you can have a default implementation inside the trait itself. Okay. So traits are very similar to interfaces. Interfaces meaning same like traits cannot be instantiated. You can't create an object just with a trait. Okay. Same feature as interfaces, the same feature or nature. Okay. You can call that sort of feature. So classes can implement multiple traits at a time. Okay. But we don't use the implement keyword, but we use extends keyword. In Scala, as we do not have implement keyword, okay, so these two are similarities. Class can implement multiple traits at a time, and yeah, the only difference is that now coming to its differences, traits can have a default implementation. Default implementation for all or any methods inside it. Okay. Now, since they can have a default implementation, so if you're going to override the default implemented method, then in the subclass, like when you have a trait, like if I make a trait, person or vehicle, any common nature, generally, what is the purpose of maintaining interfaces? The common nature, we keep that in an interface, and methods, we name all those methods, right? Now, So as we have seen there, so since we can't create a constructor with traits, or interfaces will not have constructors. This is a similarity. Traits and interfaces will not have constructors. That's why you don't see constructor parameters there. Okay, and I have two methods. So one with definition, one with the implementation, and another with just the declaration. Okay. Next thing, so if you are going to implement only the unimplemented methods from the trait, you don't need to provide anything. Def driving, def raise. Okay, this is just a declaration, but this is a implementation. Now you in your class car extends vehicle, if you are just overriding the if you are just giving the definition for race, you don't need to give anything, just println. Override keyword is not needed. But if you are overriding driving, it's mandatory to give override keyword. Okay, so override def driving, so println, so whatever your own version of implementation, car driving. So that's the only difference which I am talking about till now. And the same way, your interfaces can have a variables. Even in traits, you can accommodate your variable declarations also. Any difficulties so far?
No, we are good, Shiva. I'm good. Sorry.
Okay. Yeah. Okay. So till now there are no difficulties. Now the only point that is making your confusion is that so traits can have a default implementations. So this is more similar to the abstract classes in Java, but the traits is not a complete exactly equivalent to your abstract class, because it is not defined as a class first of all. That's why it cannot have a constructor. It has more similarities with interface, and only one difference, that is because of that you are getting confused that it acts like an abstract class, and just because of that feature or nature we don't recommend using the abstract classes. That's the only purpose we use abstract classes, right? So the purpose of abstract classes in Java, that you can have your implementations whatever the methods that you know, but the remaining methods you can leave them as is, as a declarations and mark them as abstract. Abstract class. So these abstract classes, you might not see that frequently being used in your day-to-day coding, but since I have to cover all these things, I'm just covering them. Okay. So in abstract class inside your Java, if you have, so one of the method like def drive and def raise. So in case if it is Java, we'll provide abstract. If we don't give the definition, if you don't give the implementation of the method there, and here again abstract in front of the raise, if you don't give the implementation. But in Scala, what the difference is that you don't need to give this keyword in front of all the methods. You just can declare your class as abstract. That's enough. And inside this, you can provide your implementations to any number of methods. And so unimplemented methods will remain same as it is. Okay. Now, same as like abstract classes in Java. Now coming to abstract in Java and Scala. Abstract classes cannot be instantiated, meaning you can't create an object from that. New C1 you can't use it. New traits can't be instantiated means new vehicle command you can't use. New C1 you can't use for abstract classes. Okay. But abstract classes can have constructors. That's the one difference between your trait and your abstract class. But there is one biggest drawback for abstract class, that is that we can only inherit at max one abstract class. Okay, since Java or Scala does not support multiple inheritance of classes. Okay, but whereas coming to the traits, multiple implementation of traits is supported. You should not get confused there. So is there any other differences? Any difficulties that you are?
When you say multiple, means you have to provide, you will have different interfaces, you have to provide all those functionalities, right? Same like Java.
Yep.
So yeah, any number of interfaces, but you have to provide the functionality.
Yep.
We have the same concept in Java, right?
Same interfaces, multiple interfaces implementing in Java,
Yeah.
multiple traits implementing in Scala. It's similar. So
Because internally it is Java, right?
Yep. So all the first three points are common in both Java and Scala. These two are similarities between your interfaces and traits, and this is the only difference that you see with interfaces and traits. And coming to here, so all these three are like similarities between your Java abstract classes and Scala abstract classes. Nothing different.
I think yesterday you said some constraints by only for those classes. That's the
That is the advanced topic both in Java and as well as Scala. Same if you know, how to limit your interfaces to be used by the classes. If you don't know that knowledge in Java, so if I try to explain you in Scala, that's the where you are making confusion. So that is anyway very, very rare scenario that you make it. Okay.
is it possible to explain that once more if you don't mind?
Let me check with others first.
Okay, sure.
If they are fine with till now, I'm okay. I don't want to make your job complex, first of all. If they really need it, I will explain it. Otherwise, see, there might be 100 topics. If I explain all of them, like instead of you getting complex and getting scared, let me make it simple and easy for your first step. That's better rather than scaring you and making you running away.
That's true.
I know, how much useful that will be in real time. Very rare scenarios, like 90% versus 10% use cases. I always try to focus you whether you are reaching all those 90% use cases or not. Okay, the remaining 10%, even if you don't catch it, I don't worry about them. That's my theory. Like, so no one can catch all the 100% topics. Okay. Okay. So what if multiple traits implemented by a class have similar method signature for default method? Excellent question, Mohit. Very good question. Yes. This creates a problem. Okay. Very good question. I have a slide to answer that. So before going to that, as Mamata was requesting to take me that restrictions on the traits as well. Restrictions on the traits as well. So in case when you declare a trait, okay, so just a trait T1, if you declare this as it is, this trait can be used by any class. But let me give you one example, like a
shape. Shape can be used by any shapes.
Yeah. You might have seen that in books, right? The default interface, in some examples, if you trait shape, okay, or what we call that, area
or circumference.
Yep. Okay. So shape, you have shape is an interface. A get area is the method, right? So def get area. Now, so this shape interface cannot be used by, you have a class employee, let's assume. Class employee cannot extend, that does not make any sense to extend shape, correct? It will not make sense. Employee cannot have an area, right? So to restrict that, if I have to take a class what can I say? Any generic name for all these shapes? A class circle, class rectangle, class square. So all these are again shapes only, right? I can have a class shapes as well, or
Geometrical shapes or any shapes.
yeah. So I mean, I hope you're getting the concept. I mean, name is fine. Okay, okay. Geo shapes or something, I will keep it. So now this shape trait makes sense to be implemented only for the subclasses of your geometrical shapes. Only for the subclasses of the geometrical shapes. In that case, what you can do is this colon geo shapes, geometrical shapes. Okay. So if you give this line in the beginning of your trait, then it constrains you, that it restricts that only the subclasses of geoshapes can extend your trait, and they can only provide the default implementation for area. Instead, like any, I mean, even if that doesn't make sense, the classes cannot, classes may not implement that. So in this case, class employee extending shape will not make sense. Class circle, class class rectangle, class square, class triangle, this kind of class pentagon. So all these classes, if they extend the traits, the shape, then that makes sense. So for that reason, we can make it as a restriction that only these kind of classes can extend or can use this trait. Okay, this is the only line.
Okay, got it. Thank you,
Okay.
Shiva.
So at least for now, just keep only this line. Forget about even the first criteria that I told you. It's more powerful and more useful than the first one. Okay. A trait extending a class is also there, but if you are getting confused, stop using it. This is more powerful and more useful, even in case of restrictions. Okay.
Thanks, Shiva.
Yep. Now, abstract classes, since we get the default implementation in the trait itself, and you can extend multiple traits at a time. So that's the reason even Scala developers community does not recommend to use abstract classes when it's when you have traits. Meaning you always have traits, you always have recommended to use traits only. Okay, and inheriting abstract class is nothing different than your regular class inheritances that we already talked about. I don't need to repeat them. We already talked about inheriting constructor parameters, inheriting class level variables, inheriting class level constants, the vals, and inheriting the methods. How do you override them? All those things. Okay. So now this is your question, Mohit. Yes, the same way in C++, language, we have the concept of multiple inheritance.
Yeah.
So in multiple inheritance, yeah, let me stop you at the end of slide, Mamta. Okay, just please bear with me. Okay. So we have a multiple inheritance concept in C++. There, one class can extend multiple classes, meaning class A extends class B, comma, class C, something like this. Let's assume. So the Mohit's question now is that what if the same method is present both in B and C, and if I am going to use that method in my class A, which one will get executed is the question. So this we also call as in our programming terminologies, we also call this as a diamond problem. Okay. Now, so this example will clear that question to you. So let's say I have a trait base and def op, which is a string. It's a function definition, that's it. Now, trait foo extends base, override def op equal to the inside this foo method, foo method is having foo, and bar extends the same base trait, a trait extending another trait. Okay, this is an example for that as well. Base and override def op equal to bar, and next one the trait b extends base and override def op equal to b. Okay, now let's, if you summarize, I have three traits now. In the three traits, I have the same method op, okay, and they return three different results. Now, let me take this as it is into the Scala shell. Okay, so base is created, define trait base B, define trait food, define trait bar, define trait B. Now, your question is that what if a class A extends foo with bar? If class A extends foo is fine, you don't have any question. With bar, so the class A is extending both foo and bar. Now, if I create an object for this A dot op, what am I getting? Either I should get foo or bar, if I don't know which one will get called, right? So, but I'm getting bar. And if I change the order, let's see, bar, then this time it prints me foo. If you observe the pattern, if you just observe the, okay, I lost that. So bar with foo with beer, if I use that also, so this time it came beer. If I change this as beer and this as foo, and if I make it this, So it's coming for. So if you have captured the pattern, so whichever comes in the last in the order, that will be your end result. The last trait in the order, from that order it gets picked up. So now it is your responsibility that, so what is the order that you are going to maintain? So whichever is important for you, takes priority for you, you have to keep that at the end of your all traits. So bar, foo with beer. Like, so you have extended the bar functionality first, and then extended foo, and then extended beer. So these two got overridden. Okay, the first two got overridden, the last one. Okay, so that's why the last one beer, it's returning beer. The last one foo, it's returning foo. And if you maintain the last one as bar, if I maintain foo here and bar, okay. I hope that answers your question, Mohit. So whichever comes in the last in the traits ordering, so that will take priority. Okay.
Shiva, it's like a scope of the variable, right? Whatever the scope you have it, the last one will be overridden, right? If you have same variable.
Yes, something similar to that.
Yeah.
Correct. Okay. Now, let me move on to the next topic. Exceptions. How do you handle here? So exceptions in Scala are also very similar to Java exceptions. Okay. So multiple inheritance is possible in Scala with same logic. Yeah, multiple inheritance feature is possible. The purpose of having a multiple implementations of interfaces both in Java and Scala is introduced just because they are not supporting the multiple inheritance directly. So at least they can have some method declarations. That's why Java supported multiple implementations of the interfaces. Here in Scala, it resembles more like that only, multiple inheritance, since you have default implementations into traits. Yes, but you can't say, you should not say that multiple inheritance is supported in Scala. That gives you a different picture. That nature can be achieved. Multiple inheritance nature can be achieved in Scala with default implementations in traits. Is that clear? Okay. Yeah. Now, coming to the exceptions. So exceptions are also very similar to the exceptions in your OOPS languages like Java. So instead of returning a value in the normal way, a method can terminate by throwing an exception. So for that, we can have a throw new exception, whatever the exception class that is, and we can handle that inside our try-catch blocks, same as Java syntax. Okay, I have a simple example. file handling. Let's say just example, and as well as this example covers both for file reading example in Scala, as well as to deal with your exceptions. Okay, so I took both of them into consideration. So object, my singleton object file read example, I wrote my main method, and so I'm going to read a file from my local system. So reading your files, either you can use your Java APIs, okay, meaning you can read it through your file reader in Java and make it through buffered reader, like so. Uncomment this and val br equal to, you can make it as buffered reader. Buffered input stream, or let me take okay, and br dot read line. I'm trying to print that. That's it. Okay. So just br dot read line, it returns me a string, right? So whatever the line that has, right? So this is one way. Either if you want to read through your Java, your file reading API, file reader and buffered reader APIs, or in Scala we have input type, output, source types. Like so io.source class, generally this is more famous and more popular we use than your regular Java APIs here. So source dot from file, and this can be your directory also. You can give, I think, from path as well. Source dot from bytes, from char, from file. You can give a directory as well to that, not just the direct file. You can give the entire directory also for that. Let's not worry that right now. So source dot from file, and give the path of that file. Now this file will get so from file means that path will be converted into a Java file object, and this source can start reading that. Now from that object, the source of whatever it returns the object, from that you can make a call to get lines method. So this will return a collection of lines. It treats that as each line as an element, and that's a collection of lines, right? Any file means. So for every line in this collection, so I'm going to print that. So inside here I'm just printing. So inside the for loop, whatever if you want to do with that line, whether you want to parse it, whether you want to break it, just make it into fields and do some other filtrations, whatever you want to do, you can do that. Now, so both the two different ways, I'm trying to read a file. So generally, whenever we are dealing with the files, there is a chance that the file is not present at that location. So the same Java exception classes, you will see, you will see the same exceptions being thrown from Scala also. So it can throw exceptions now, case EX, so whatever the exception that it throws, case EX colon file not found exception. If it is a file not found exception, so println missing file exception. So if it is IO exception, println IO exception. So finally, exiting finally. Okay. Now let's see. Run configurations for this. File read example. I just gave one of the random file from my downloads. I just gave one of my datasets JSON syntax. So any file is fine for me, not a problem. So if I run it, so this will get built and then it prints that. Okay, so this is the first line printed by your buffered reader println. The second line is printed by the same, both the way scenarios. I'm just printing that is through the Scala API. Finally, there were no exceptions. That's why you got this thing. Finally, exiting. So you didn't get any exception right now. So if you get an exception, if that file is not present, if I give something that is not present there, I just make missing file exception. It got catch. That's right. So same as your Java, you can throw new exception from here once again, like what is the type of exception, or your print, you can print your stack trace. Everything is possible. Same like your Java exceptions. And you can even write your custom exception classes. So let me show you that custom exception classes in the next slide. But now, so here is one rule that we have to keep in mind is that mind the catch order. Okay. So generally in the case statements, this is like a case is nothing but a pattern matching, right? Here. So in pattern matching also same, a match in the curly braces, we had all the case statements. Here we are using the catch statement. Inside the catch, you will not have multiple catch blocks. First thing, that is one difference that you guys have to catch. So you don't have multiple catch blocks, but inside a same catch block, you can have a multiple case statements. Else catch, you don't have like that, same as in Java. So in the same catch block, you can have multiple case statements here. The order of the exceptions, let's say the exception arised is of this type. It executes these lines and it come out of that catch. And if the exception is of, if it is not of file not found exception, then only it will go to IO exception. And since all these exceptions might be inherited nature, so an exception might be a subclass of another exception, like all the exceptions in Java are a subclasses of your superclass exception. This exception is the superclass for all the exceptional classes, right? And string index out of bounds exception, array index out of bounds exception, file not found exception, IO exception, all these exceptions are just the subclasses of your exception. Okay, if you take this in reverse order, so even IO exception is a subclass of exception, and file not found exception is a subclass of your IO exception. If I make it as exception, it's just a exception. Okay, let it be taken from Scala itself then. Okay, so if I run this in this order, there is nothing changed. But if I put these two the above, let's see what will happen. So the same file not found exception, it has raised a file not found exception because the file is not there, you know that. But file not found exception is a subclass of IO exception when it is matched with IO exception. So when it's comparing, it matters that your subclass object can be compared with your superclass object, right? So is this a type of IO exception? Yes. This is also file not found exception is also one of the type of IO exception. Then it matched the first scenario itself, then it came out. It didn't go for whether it's a file not found specific. Then if I put exception there, exception is a superclass for all of them. The same thing, like you will not find the other two also occurring ever. So what I am trying to convey here is that the exception order matters here. Okay, so always specify the specific exception at the top and the more generic exceptions at the bottom. Getting it right? Okay, so that's the first case matches exception and all of its subclasses when using multiple catch blocks. So we must ensure that exceptions are being handled by catch blocks you intend. If in case of Java, above example will raise compile time exception as, so exception string index out of bounds has already been caught. But here, you'll not see that. Okay.
It's all similar to Java, right?
Yep. It's all similar to it.
Okay.
And in case if you same like in Java, so in front of your method declaration, if you want to specify the annotation that so this method can throw this kind of
Exception, right?
exception, you can specify that. Same like at throws. This can throw IO exception, this can throw file not found exception. This is just purpose.
Yeah. Is Scala is more of it's wrapper classes around Java? It looks like most of it, right?
Yep. So defining a custom exception, it's nothing much difficult job. So case class, whatever your application exception that you want to write, give a name. So just give a message. Extends exception class, which takes in a message as a parameter. That exception message. So use this. That's it. So here, if you see here, state capitals, I'm using directly map here. Anyway, we are going to discuss the collections in next few minutes. So state capitals dot get Alabama dot get. So when I'm getting this, if it throws any exception, if that is not present there, so then any kind of exception from here, so will get captured into exception first. From there, I can throw my new custom exception. Okay. So that's how we implement the custom exceptions there. Any questions there?
No, Shiva,
Oh.
I'm good with this.
Okay. So any questions, Purushottam? Okay. I can see someone. Dilip? Is this Dilip from US candidate or is this Dilip? I don't know. I'm not sure. Dilip? Hello, Dilip? Okay. Seems like he's not able to talk. Okay. Now, yeah, let me take up the collections and then we'll wrap up. Let me show you how to build the Scala applications through Maven build tool. And SBT, I will try to take it up through the Spark examples itself directly. Even Scala, Maven build also, I will show you with the help of Spark application building only. Okay. Yeah, before that, so let me take up the collections in Scala. So it's more or less similar to the collections in Java. So there you might have seen list, map, and set. Here we call them as a sequence, map, and set. So sequence is a equivalent to, sequence is a superclass for the lists. So mainly these three categories. We have others also, but before going to them, so you should be using these very frequently. So a sequence is a linear collection of elements of same data type. So these collections are like a homogeneous elements, collection of homogeneous elements. Okay, so it's a linear collection of elements and may be indexed by creating an array list or a linked list. Okay, but we mostly use 90% of the scenarios, 99% of the scenarios, we use lists only in Scala. That's about that. Next, a set is also a collection of homogeneous elements, but the difference is in set you will not have a duplicate element. Okay, and the third type is a map. Map is a collection of key value pairs, same like a maps in Java. Other than these three categories, you may, if you want to use some kind of stack or queue, you may try with them as well. Stack, queue, and range also. But even more than that, you see in real time in Scala. So tuples being used more frequently, and sometimes option, sum, and none being used. So when you don't know how many values a collection is going to contain, then you can maintain. I mean, when you don't know whether a field can contain a value or not, and you want to take that as a collection, and that may get a result or may not, then you can specify that as an option. Option means either 0 or 1. It's a collection element, collection type. It can contain either 0 or 1 element. So out of that, the specific classes, there are two subclasses for option. They are sum and none. Sum means there will be one result, and none means there is no result. These two are subclasses of option. And tuples are the ones that we have already seen. Sum is a container for one element and none holds 0 elements. Now, all these are homogeneous collection of elements, like a collection of homogeneous elements, whereas tuple supports the heterogeneous collection of elements. You can have a different data type elements grouped together. And declaring a tuple is also very, very, very simple. Just put all your elements in parentheses, that's enough. Now, if you go to the internals of tuples with ranging 1 element to 22 elements is only possible because in the background, tuples will get implemented through the case classes. And case class has a limitation that it can take maximum of 22 elements. That's why in Spark SQL, by default, you can't create a table more than 22 columns. That's the default nature that we observe in Spark SQL. That time I will show you a solution how to write a custom case classes so that you can have a tables with more than 22 columns.
Case will have performance issues?
No. Dilip, can you hear me? Hello?
Shiva?
Hey, sorry guys, I think there was a network drop in. So, yeah, I was just checking with the Dilip. I'm not sure. Dilip? So, is this Dilip from Hyderabad or Dilip from. Someone called me from US also. Not sure who is showing. Dilip, can you speak out? Whenever I ask him, he's just okay, disconnecting. Okay. Yeah, fine. Let me. Okay. So for the different type number of elements in the tuples, we have a different tuple classes like tuple 1 to tuple 22. But generally, we don't use these class names to specify the tuples. Just specifying the parenthesis is more than sufficient. Okay. Just give me a second break. So I'm getting some background noise. Let me close my windows. Okay. So let's see like different types of collections and a few examples for them. So again, in collections, we have two flavors. So one with mutable capability and others with immutable. Okay. For every collection, you will find these two flavors. Like, so Scala favors immutable collections a lot. And by default, if you start using any collection, it brings that collection with an immutable state. Okay. So immutable means you can't change the size of it. You can't change the elements of it. So once you created it. If you want a mutable collection, so most of the times, since we are coming from the Java background, if whenever we create an array list or something, so we keep on adding elements to the lists, right? So if you need that nature, so we need to go for immutable collections. But by default, you will get a immutable collections into your Scala if you don't specify which one you want to go with. Now, all the mutable collections are present in this package, scala.collection.mutable, and all the immutable collections are present in this package, scala.collection.immutable. Okay. Now, let's see the most frequently used one, the list. It's so Scala lists are quite similar to arrays. The reason why I'm comparing with arrays is that a list is a immutable list. You can't change it. So once you define the size, once you define the elements, that is fixed. All the elements of a list have the same type, and Scala list class is immutable. So it's a size as well as the elements it refers to can't change. An example for defining a list, it's implemented as a linked list in the backend behind the scenes. But so this is by default, it's an immutable one. So if I declare any list here, val fruits, which is a list of strings. So now fruit is a list with these 3 apples. So here val fruit, it's a list of apples. I can't change this. And nums, list of integer, list of 1, 2, 3, 4. And so you can even declare a empty list, well, empty list of nothing and list. And you can even define a 2-dimensional list of integer. So list of 100, list of 010, list of 001, this way. And other way of declaring them also is like, so here 2 colons are used to concatenate two elements. An element with a list. Generally, the 2 colons in Scala is used to concatenate an element or a prefix or suffix an element to an existing list. Here, nil is an empty list, and to that list I am prefixing PS, and now this entire thing will become a 1 list, and to this list I am prefixing another element. Now this becomes another list, and to this entire list I am prefixing another apples element. Yeah, this is very rarely used syntax. Only thing is that even if you encounter this syntax, you should not get surprised. Okay, this is also nothing but a list declaration only. Generally, this is the more frequently used one and more user-friendly. And so here you will get confused if you have many elements. you'll get confused with these many parentheses. Okay, don't worry about this second syntax. So some of the basic operations that you can do with this is like, yeah, the better is you can play with inside your the same value fruit. So try, if you want to know all the operations. Fruits dot. So what can you do? Plus plus means concatenate with the other list. The same can be achieved with triple colon also. Double colon is just to a prefix or suffix, another element to it, the existing list. Okay. So collect. So fruits dot collect. It builds an array. It returns all the elements of that. And drop of an element that is present in the nth position. Okay. Drop while a condition is true. Until then, fields will get dropped. Flat map we'll see in Spark directly. Okay. So fold right. Fold right is something applies a binary operator to all elements of this list and a start value going right to left. Fold right. So you can try with them. Generally, the basic operations that I will first right now So map, you have an idea. Filter, you have an idea. And reduce, you have an idea. For each, you have an idea. For each is nothing but iterate through each element of it. You're not specifying any operation. So whatever the function that internal, what anonymous function that you give there, that will get executed for each element of this. The same case for map also. Whatever the anonymous function that you have inside your map, that will get executed for each element when you call it through map. Okay. So reduce is an aggregate function. So it combines all of them. So with the operation, with the anonymous function that you have specified there, and it gives you one result out of it. Generally used for count, sum, average, or anything that you can do with your reducer in your map reduce. The same purposes you can use it here. And if you want to reverse a list, you can do that. If you want to split, if you want to take first n, take off n means it takes the first n elements. Take off 5 means it brings the first 5 elements. To list, it's already a list. You don't need to be a list on list. Add a string builder. Apply, it's not needed. Collect first to check whether an element contains, whether an element is present in this list or not. List.contains of, okay, list.contains of apples. It returns true. Okay, so that way that is contains. Yeah. So I don't need to like a spoon feed by each and every of these methods, and it's not possible for anyone to take all these things also. So I want you to at least thorough with on collections, like some of the methods like a map. For each, both purposes are similar, and filter and reduce for now. Like a plus plus for concatenating with another list, and contains to verify whether an element is present inside that or not, take to get that into take 5, it brings only the first 5, and mk string is there. So this will convert this entire list into a string, mk string of delimiter you will provide here. So all these things will get converted into comma separated. Apples, comma, oranges, comma, pears. This will give one string with that comma separated. So these are the, and maybe, yeah, head, tail also might be sometimes useful. Size is useful. List.size. Okay. So as long as you have Eclipse, you don't need to worry about them. Just on your list dot control space, it shows you all the available methods. Then, so whatever by the function names itself, you will get to know most probably. So, but these are the bare minimum list that you should at least have a basic idea. Okay. So you should have an active knowledge on them instead of passive. Okay. So now, yep. So head means it gives you the first element. Tail means other than the first element, all other elements will be written. And is empty can be called to check whether that list is empty or not. Okay. And if you declare a list, if you assign a list to a var x, then this list, that var x can be keep on changing. If it is a val, I can't add this to. I can't assign this. First of all, since this is a val, I can't reassign this. Var x equal to list of 2. So if I want to add, I don't have direct methods on x dot add or that way. I have to x colon 3 element 3 or whatever. I want to list of 0 or this way. So either in whichever order. Okay. So prefixing an element, how can it's not suffixing? So the other way of syntax is plus colon is also possible. Colon plus 2. Then let me try with this. Yeah. So for suffixing, so colon it's not the syntax. So colon plus or plus colon are like a prefixing and suffixing syntaxes. Okay. So concept-wise, simple. Syntax, you see this double colons, colon plus colon, or all those are like alternatives. Either one. You can stick to one of those syntaxes and you can keep on using them. And these are some of the operations. If you want to make your list as a mutable one, we have a list buffer. But we have to import that because by default you will not get this mutable package imported. Import scala.collection.mutable.listBuffer and fruits plus equal to apple. It adds an element. Fruits plus equal to banana. Fruits plus equal to orange. And fruits plus equal to strawberry or this thing. But here, when you use a list buffer, so you have to make it as a var instead of val. So this is already a collection. If you want to add another list to it, add multiple elements at the same time. So plus equal to strawberry, kiwi, pineapple. So this is a list getting added to another list. And from the list, if you want to delete one element, minus equal to apple, minus equal to delete a complete list also this way. Okay. So here, this is like a just specifying comma separated elements. If you want to make it as a sequence, meaning a list this way, then you have to use double hyphen, double minus, or double plus plus if you want to concatenate them. And a list buffer can be converted to list so that it cannot be altered once it got converted into list. Okay, some of them are like a list.reverse and list.add string, list.contains, copy to array, list.distinct, and list.drop so and so element. These are the methods that you can play with them. You can practice all of them in the shell itself. And set is also similar to a list. Only thing is that it doesn't allow duplicates to you. Okay. So list interfaces are array list and linked list. In Scala use arrays also. In Scala use arrays also list. Arrays also list interfaces. I didn't get, not getting your question.
List interfaces we are using array list and linked list and something. But in Scala, you told me arrays also using list interfaces or what? I'm not getting.
Arrays are also using list interfaces. Okay. But the concatenation of the elements in the arrays is not possible through these double colons or these kind of syntaxes. You still have arrays and lists in Scala. They both function a bit similar. Like a list is also immutable one, and array is also an immutable one. Once you define the size, you can keep on adding. So to add that to an array list, arrays, you have that add index wise. You can keep on assigning your elements to that. But here list, when you compare with Java list, you can't add elements. You can't keep on adding elements to it and removing elements to it that easily, unless until you use your list buffer. That's the difference between your array, list, and list buffer.
Okay.
Okay?
Okay.
Yeah.
Shiva?
Yes.
Shiva?
Yeah.
When we have mutable and immutable both, which is better? And immutable, in a way, it is going to drop off and create a new list like string. Like string, we really cannot add it, but whenever we create a change this string, it is inside, it is going to drop and create a new one.
It points to a new reference.
Sorry?
It points to a new reference. Okay. So if you assign a value to again existing string, it points to a new reference there, new object or string.
One thing I did not understand, but if it is really used using the linked list, right? Adding an element in the linked list is easy because it gets the memory allocated and it's a real pointer thing and do it. And there,
yeah, the performance point of view, the search results, generally we don't use linked list.
Complexity of the search results you are talking about.
Yep.
Time complexity.
Whenever you are maintaining lists, most of the cases, 95% of the cases are for search that back. And
Yeah, the
you
performance
have
is.
an extra overhead take. Your linked list will be relatively very slow in searches. So that's why we don't recommend use a linked list.
Oh, so no, my major question was this. So what is the preferable one in the real time, and what are the major disadvantages if we use the advantages if we use the immutable list? That's where my focus was.
Okay. Uh, so it depends on your scenario first thing. Okay.
Mm-hmm.
So if you know the list of elements inside, yeah, let me put you in mute. Okay. Let's not, you don't need to, yeah. The first thing, if you know the list of elements in prior in hand, if you know that you're not going to change the elements, let's say, like um, days in a week, if you are going to maintain somewhere, and if you want to play with that, you can have a plain list. Because why? Because you will only have a 7 days per week. You can maintain that, or months, or something like anything that you can see like a constant list. You can go with a immutable list. Okay, and anything that you don't know what are the elements are going to be, based on the iterations, based on the process, if you keep on adding, if you want to have your elements keep on adding to the list, then it's always better to go with the list buffer, the mutable one.
So otherwise, if I don't know the list, if I'm adding one time, I can add it to the new list and I can concatenate it, right?
Yep.
Because when I
You
practice
have to
list.
create a one more list, concatenate this, and if it is a, again you have to reassign it to a one existing one, like so var x like something. So if you are declaring it as var x, so this like you will get confused if I go bit more internals into this. But if you declare that list itself as a var, when the var variable, you keep on adding into it the same x.
I got it, because var is variable. Like if it is val, we
You're
cannot change.
reassigning that itself to a new list. So the right side is a new list. X suffixed by this is a new list, and you are reassigning that to X. So I'm not trying to make you confuse here. So I'm not doing.
I got it what you're saying, because I practiced couple of, because I wanted to know what is the best to use what scenario, because I know in Java, I mean .NET, not in Java. So to do the things. So suppose like we have, when you have too many things, we have some performance overhead and those things.
Correct.
So I was concentrating on those. When you
Did
get
you
a
get the
bigger,
examples about what I'm trying to take? Like a days in a week, or a month, months in a year, or some list of products which you are going to deal with, or the list of stores that you are going to deal with. In case if I want to make sure that. So if I'm going to get a list of products or a stores inside my um, Spark application. So from one of the table, if I'm going to write a native program or something, if I want to get all the store names, so I will get that through one store name. And if I want to make it as a list, I can make it as an immutable list, because once the store names are read inside a Spark applications related to all the stores, it's not that frequent that stores will keep on adding inside it while the program itself is running. Correct? In a city, if you take a retail stores, that's a constant list, at least for a week period. You can't expect like a store being added every 1 minute or every 1 hour or something like that.
I got that. Yeah, that's what I wanted.
So anything that you see based on your case, when you are getting a group of elements, and if you feel like this list is not going to change throughout your application, then you can make it as an immutable one. Otherwise, if you see something like a count of like something that keeps on changing. So how can I take example?
No, I got it. I got it, Shiva. This one, the context, what you are saying it. Suppose, let's say that you're getting from some table, you're adding it. I got it, because that's where my question was. Based on the scenario base, I got it. If it is a changing things, immutable.
Yep.
And if it is constant, use the constant, we know how many elements we are going to get.
Exactly.
Suppose, let's say if I want to get 100 rows, I know that like count 100 rows, I'm going to declare only that list.
Yep. Correct.
One more quick question. I don't know whether it is good. So when I read, I also read about vector, because I know I have other questions.
Vector is a very old collection type. Even
no. I wanted to know the difference between the vector and a list. I know set is like distinct list, but vector and list was very close. I was not sure when to use vector and when to use list.
Don't use vector at all, first thing.
Okay. And how about view?
View?
View, V-I-E-W.
A view, is it a collection? I never used it.
Really? Okay, so I just read from that book. I have to check it out, because I did not get it because they were using it. Okay, let me just check it and come back to you later.
So for your first question, why I'm not recommending to use the vector. Vector is one of the old collection type. Okay. So before even the lists came into picture in Java, so you don't see vectors being used in Scala. I don't think so. Okay. There might be, I mean, many things, but coming to the reality, I mean, real-time usage. So in my experience, last 2 years or 3 years, I never used vectors. But vectors are like very slow in performance when compared to the lists.
Yeah. Those things you want to know, because we have many things like as table and there are so many things, which is the latest one I want to use that. That's the reason I had this question. And view, I'll search it. If not, I'll get it.
Okay. Yeah, fine. And I think so. Yeah. So shall I go ahead? Start with sets.
Sorry.
Yeah. Shall I start with sets? If there are no questions.
Please, and ask the team. Thanks, Shiva.
Okay. So then set. So set is also similar to a list. Only the difference is that it will not accept the duplicates. Again, in set, same as your lists, we have both mutable and immutable versions. If I create by default a list or a set, if I create a default set like your var x equal to, ideally speaking, if you are using the default set, you have to make it a val set of If you observe here, by default, it took from immutable package scala.collection.immutable.set. Okay, and more or less you will find the same functions as list even in sets also. Set.contain, set.make string, set.for each. Even that is also like a collection only, right? So you can also, you'll find all other functions, all the functions that you have seen in the list as well. Now, in this, all these functions we have already seen. So if you want to have a mutable set, you have to declare it as a var and use var as I'm telling here. And you have to use the fully qualified class to make it to make it that you are pointing to mutable set. Otherwise, by default, it brings in the. But in lists, you have a list class separate and list buffer separate. But here, you have the same set class in both the packages separately. Okay, class name is same for sets. And even for map, the class name will be same. Only for list, you have a list in immutable and list buffer in mutable. Same like a string and string buffer. Okay, on this immutable one, same like if you want to add elements, concatenate elements, you can use this. So if it is a mutable one, you can add elements, and if you want to remove, you can remove elements. Okay, so that is one thing. So inside a set, you have these additional methods also: min, max, and size. And MK string, as I was telling you already, convert all of the elements into a one string. It is specified by the delimiter that you specify there. Take is to take the first n elements. Take of 5 means it prints only the first 5. And the next important collection type is map. Map is nothing but a key value pair. And again here you will find the two flavors, both mutable and immutable. So immutable.map, by default it gets created, and when you are using a map immutable, you have to declare it as a val. But when you are importing from the mutable one, you have to declare it as a var. If you mix them, if you interchange them, you will be leading into confusions. That's why, as a coding standards, as part of Scala best practices or coding standards, so if you are using any immutable collection types, you have to declare them as a vals. Otherwise, inside your program itself, if you keep referring that, if you keep appending elements to it, making a list and reassigning to the same list, it makes your understanding and others too leads into confusions. Okay. If it is an immutable one, if you are bringing it, make it as a val. If it is immutable, make it as a var. And here, keys in the map are unique, but values need not be unique. It can be duplicates. Okay. Now, so this is just a simple way of defining a map. So the same way a map, list or set, you can specify the elements, right? So here you have a key value pair. So we separate them by arrow symbol. So anything that is left side of arrow is key, right side is a value. Now states, if I make it as a mutable here, states.add of, I can specify that anytime a new key. And here map of, just I specified this list. This is an immutable map. And if I want to loop through the keys of it, so just, and the operations on them are like a pretty simple. You again have to make use of your Eclipse to know all the types of operations that are possible. just explore all of them. Colors dot to map is already a map, plus plus with another map. Collect first, contains, drop, exists for a key value pair, filter is anyway fine. Get of a key, generally we use this. If you give the key for a particular key, what is this thing, and all the keys you will get with the keys method, and you can get that key set also separately. If you get keys, map like keys, it gives you the iterable one, and map, min, max, mk string, all those things are available here. Size of the map, okay.
So in this, most of it are general, we can understand. Only one thing I did not get was fold left, reduce.
Fold left is not specific inside this, and fold right is also not specific inside this. I will try to take an example during the Spark itself. Okay.
Not a problem.
Yep.
Thanks, Shiva.
Fold left or fold right, so we can see that there. Colors dot keys, colors dot get of a key, something like that. So again, this is a list for each. You can look through the println. It just prints in that line, right? And yeah, get of a key is also a regular one. So next, the more frequently used ones are like a tuples. So you can declare a tuple, just, you don't even need to give a tuple 2 or tuple 3 kind of syntax. This way you can give, even if somewhere if you observe in your code, so you have to take that as similar to this one. Just 4, 3, 2, 1. It's a tuple of 4 elements. If you want to access them, just this t dot underscore 1 for the first element, underscore 2 for the second element, underscore 3, underscore 4. You can define any number of elements. No, any, when I say any, up to 22. Okay. The next one, I have iterator. Yeah, there is not much use of iterator. So just, yeah, whenever you see any code, so for that sake, I'm giving you. The same way you have iterator in Java. So to iterate over each element one by one. So on any list or a collection or map or something, so you will find that to iter method as well, and iterator dot has next. So as long as it has a next element, you can loop through them. But we don't recommend that to developers to use that. But using iterator for collections is not a good idea, as we already have a map or for each methods and collections to iterate through each element. Only case is that when you are reading a file, you might put that. Okay. No. Yeah. So at least now you know basic functions like for each map, filter, and reduce. These things we use a lot. Okay. In Spark. You'll see that there. And using Java code in Scala, do you still think that, am I left with anything to explain in this slide? Because we have seen some examples already. We were using some of the directly this, for example, so I was creating the objects of Java classes inside our, yeah, I can even do it right away. Let's say I have this pizza test.java. So what is the class that is present in this? So pizza Java. Okay. So if I call this pizza java.describe, pizza java.print message. Let me take this. Okay. So pizza java.print message. If I call this method from one of my Scala classes, so that makes the proof, right? I'll just make it as new pizza Java. This is the one, new pizza Java. Print message. This itself tells you that I can call it. Otherwise, it will not even prompt that, right? So let me comment out all this stuff. So inside my extends app, this is the only executable statement. Let's save it first. Yeah, the interoperability between these two is like, it got executed and printed there. Nothing new that you learned in this. We have been seeing the same thing. In the same Scala project that you are going to create, you can have your Java classes also written there, and you can have your .scala classes also written. You can create an object of your Java classes always inside your Scala, and you can create an object of your Scala class inside your Java class also. Now, let's do the reverse. I have a pizza Java class present in this, and I created an object for that from my Scala, and I executed the Java method inside Scala. Now let's do the reverse here. Let me comment out these stuff in my main method. Now what I will do is, so I will create a singleton test object. So here we can create s1 equal to new . That's it. Over. S1 dot. What are the methods that are available there? The print message. Same print message is available there as well. Print message. Only thing is, when you are writing in your Java, you should write in Java syntax in the time of object creation. When you are writing in Scala, you have to use that Scala syntax. Meaning, here you use val equal to val obj equal to new class name, and here a class name and obj equal to new class name. The keyword, this syntax changed. Even this got executed and printed there. And yeah, not just these examples. We have seen our file read example also, right? So file reader, all these are like, so file reader is nothing but a class from your Java, right? So val equal to new file reader means you are making a call to this file reader. Here and file not found exception, buffer reader, all these are Java classes only. I'm able to import them. I'm able to use as good as like your Java. You're not able to make any difference. Yep.
How do we use R language in Scala?
R language and Scala.
Yeah, do you have any idea?
No, Mamta.
Okay. No, I was more
First of
interested.
all, can you do that first?
Sorry?
How can you do that first?
No. I read in Scala supports all R language. So you were talking about Java and Scala, right? So I wanted to know, do we have such things? So
I don't
that's
think so. Scala supports R. Is R also written in Java?
no, it's not in. So I read somewhere. So I just wanted to.
Okay.
I just read somewhere, so I just wanted to know.
Okay. All Java and Scala code should be same package, right? Need not be. Kalpana, need not be, because this java.io, see, if you don't want to give that fully classified, fully qualified imports or something, if you have them in the same package, you can directly use them. Otherwise, you just import them. That's it. Here, in my file read example, see, these are not in my, like these are in my file reader in IO package, Java IO package. The buffer reader is in Java IO package. I'm able to use them. Right? You just have to, if it is in a different package, just specify the package in the import statements.
What if I have the same class name in both Java and Scala?
Both Java and Scala. So then the better option is use the fully qualified class name at the time of usage directly.
Okay.
Okay. So here itself. So if you have the same file reader in both Scala and Java, if we assume, then we use scala.io.file reader, fully qualified class name, give it that. It resolves your conflicts.
Okay. Yeah. Thank you.
Yeah. Okay, it's one another, the same with date formats given. Now, yeah. So let me show you just one thing. Yeah, it's nothing new in Scala. First thing, building your Scala applications using Maven. The same way you use Maven build tool to build your Java applications. We use the same approach. But for simplicity, I will take a simple project and I will write a Spark code into that, and I will provide your dependencies there, and then I will build it. Okay.
Please go a little bit slowly so that I can see, because I'm new to it. This Maven, I never used it, so that I can see the video and I can refer later.
Yeah. So you can create any project. So first, at the time of creation of project, yeah, let me keep you on mute. Yeah, we don't want a line by line. Okay. Now, first, let me create the project. Scala project. Okay. Spark by example. Okay. So you can specify whatever the environment, equivalent Java environment for that project level. You don't need to touch all these things generally. By default, you can keep them as is. Okay. So So complete the project. Okay. Now you convert this project into Maven. So configure, go to convert to Maven project. So if you want to get this done by Maven, okay. So as of now, your Maven is it's pointing to Maven compiler plugin, just 3.3 version. So let it be there. Now, if you are going to write any program, let me take some simple Spark program, the pi calculation program. Don't worry about the logic, all of that right now. Okay, so just move that Spark pi. So I have written a Spark pi.scala program. So here, see the default Scala packages, the Scala commands it's able to identify. When I'm pointing to some of the Spark code, it's not able to identify because we don't have the dependency packages available. So one very rudimentary approach that you can do is, you know this class path, you find what is the jar that is present there, and then download that jar and add to the project using build path. Okay, using build path. So configure build path. So libraries, add external jars, and so include that whatever the jar that you have downloaded that contains this package and class names. This is a very basic rudimentary approach, like in real time, the time of project building. So it becomes hectic in managing the jars if you use that. That's why we depend on one of the build tools. They maintain a central repository of all the rules. So this is, I'm explaining you this much in detail, only keeping you one thing in mind. The others are, I think, are from Java background. Yeah, they are. So they are aware of like bit Maven, how does the deal with Maven build and all.
Yeah. This is the first time we ever seen.
Now, so this Maven is a central repository where if it once downloads any jars, it will not re-download again and again if that jar is used in somewhere in another project in the same Eclipse, in the same machine. That's one advantage. Now, you just have to specify. You don't need to download and specify, add that to build path. Just specify the Maven dependency into your pom.xml file. Let's say, how am I going to solve the same problem now? So here, this Spark context, where am I referring to this? In this package, right? So in this package, Spark con, I'm referring to it, right? When I don't know okay. So Spark context Maven dependency. So if you type in the Maven dependency, let me remove this then. Just the main. Yeah. So if you type the main the package level, so you'll find the Maven dependencies, Maven links here. So what do you? It is telling you that arc.apache.spark is available in this Spark core jar, Spark core underscore 2.11. So in all these places it is having. Now, so let's say if I take Spark core 2.10, if I click on this, you will get all the versions of it. Okay. Now, if I want to refer to Spark 1.6 version, so you can see the version of the Spark 1.61. So if you click on it, if any of the version, you will get the dependencies for all the build tools. Okay. This is a Maven build tool, and slowly in the time of Spark applications build, we see it through simple build tool also. That time we take this, but for now, let's see only the Maven build. Just click on this and copy it and use in your dependencies section of your pom.xml file.
Will be the XML file, Shiva.
What is it?
Where will be the XML file?
It will be at the project level. In the once after you convert your project into Maven, you see the M symbol and you will see the pom.xml file getting created.
Okay.
So you have to add that into dependencies section in the build area. So once after you complete this, the build tag, after that you can specify your dependencies this way. Okay. So here I have in this. Okay. For you guys, so along with compilation, I have also given a jar with the dependencies plugin as well, so that all the dependent jars also will combine into your final jar. That reason. So why you can take this pom.xml file that I have given for you. You can replace this as it is into your pom.xml file. You can replace it completely. No worries. It is spanned in two pages. Now take this as it is. So here you specify the version, whatever. So we were looking at 2.10, 2.10, 1.6.1. If I save this, no. So I saved this, but still you might see some error messages here. So I have added the dependencies into pom.xml file. Just right click on the project, go to Maven and update the project. Just update only that project. Okay, don't need to update all of this. So it now downloads all the jars for this. In this case, the Spark underscore 2.11, 2.10, and inside that jar, if it is referring to any other dependency jars, all of them will get downloaded.
Means I need not to go to VM for Spark. If I have it, I can work on my machine, right?
No. Let me come to conclusion. Yeah.
Sorry.
I think you still have a problem. Project 11. Spark by example, Scala version unknown. Okay. So all of them are quick fixes. Open project preferences to set a compiler. Scala compiler. It's fine.
Quick fixes
Yeah. Just a quick fix.
means what is a quick fix?
See here, the error message, what is the error message that you are getting there? It's saying that Scala version is not specified.
Mhm.
Right?
Because it's totally new to me, that's why I'm just asking. It might be silly, don't feel bad.
Yeah, I mean, but this is more of like a Eclipse sessions, right? So
Yeah, I know. Yeah, it's not part of Scala.
So quick fix them. So if you ever see the small cross mark there, that your Eclipse is suggesting you some quick fixes to that.
Okay.
So what you just have to do is, it's saying that the build path is cross compiled with an incompatible version of 2.10. In case this report is mistaken, this check can be disabled in the compile the reference pages. Yeah. Either I have to disable this. Let me see. Open the project references. Build manager. So all those things are fine. Maven. Okay. So here it points to Scala 2.11. Yeah, only thing, the quick thing that I can do is I can make this also as 11. Okay, the thing is, by default, I was pointing to the Java build path. So 2.11.7, the latest Scala version. But here we saw it like a 2.10, right? So I thought by mistake I gave it like, you will find 2.11 Scala version also, as you can see here. The Spark Core underscore 2.10 means it's a Spark Core package with a Scala version of 2.10. Spark Core underscore 2.11 means it's a Spark Core with Scala 2.11 version. Okay, I just pointed, since there was a Scala version mismatch, I just removed it. Okay, so now for your question, so if you have this, I don't have any error message at this moment. As long as you're not referring to any file system, you can run it inside your Windows Spark Eclipse application itself. So in this example, in this simple example, I don't have to deal with any file system here. Okay. So Spark context file system by default, if it is pointing to local file system, it expects that in the Linux local file system. If it is pointing to HDFS, even in that case, you need your quick start VM, both in local and as well as HDFS. It needs that either Linux or HDFS. You have to run it from your quick start VM. So as long as you don't have anything to refer with respect to file system, and you don't have to create any files, that's fine. You just have to do calculation and print it on a console and take the input just from the just command line strings or something, then you can do this. It's like a static input and printing the results on the console. Then you can try in Windows itself. Now, yeah, let me not worry about the code explanation at this moment. Just run it as a Scala application. What's happening? Yeah. So finally, it got executed and printed its result on the console. So to summarize the steps in Scala Maven build, I have given you guys with even the basic simple screenshots. So just create a Scala project, okay, that you are aware of it. So first Scala app, and then convert that, right click on the project and go to configure. I have given you the steps also very clearly, and convert that to Maven project. And once you convert that into Maven project, you will get the pom.xml file, okay? And in the dependencies tab, you have to add any of the highlighted packages. When you have written your code, whatever are highlighted as a red underscore, that means that dependent packages are not there by default. You have to download them. So you have to add them into the dependency. So for your first cut, I have given you the simple code, and it's dependent pom.xml file, all the pom.xml file which specifies the Scala plugin, Maven Scala plugin, and compiler plugin. You can, and this extra plugin for jar with dependencies also, this will be useful. So you can keep this and you can build a jar. And once you build it, you can see the jars automatically created in the target directory. Okay. Okay, I think I didn't build it. So one thing that you can do it, I just ran it. So if I want to build it, just clean and stuff. You will get a jar file and you can run it. Yeah, in real time, what you will do is, yes, this how you build it through Maven, run as Maven build, clean install, the skip test. You will get the jar file here, and you copy that jar file onto the edge node, and there you will submit your Spark submit commands. Okay, so let it build. So once it builds here, you will see two jars getting created. So one without the dependencies, one with the dependencies as well. Meaning all the dependent jar will also be combined into that one common jar file. So that with the dependencies jar will have very huge in size, around 100 MB or so. Without dependencies, it might have, depending on your code size. That's it. Okay. So once you have that jar ready, you can take that onto your edge node and run it as a Spark application. Okay. And SBT, I will show you during Spark itself directly. And with this, after a long journey for 10 sessions, I think, right? 8, 9 or 10 sessions in Scala. So I'm trying to put a closure to Scala here. And tomorrow we'll get started with the Spark. Okay, I think we are already getting delayed. So let's start freshly with Spark tomorrow. And I will give you some assignment requirement for this week to build a dummy pizza project, pizza order project. Okay. So I will give 1 week or 10 days time. If you guys can't submit that, I can give you the source code also. But my expectation is that you guys have to complete that. Okay. So whatever the concepts that we have discussed so far is more than enough, at least to complete that dummy project, and is whatever is needed for your Spark. Okay, finally build success here, you can see. You can see the simple Spark with the dependency jar, and with this is without dependencies. Okay. So if you build it, you take this jar into your edge node and then run it as a Spark application. Okay. Any questions so far?
Thank you, Shiva.
Yep.
This one has said that you will not have file system or HDFS. Then only we can make it.
As long as you're not dealing with any file system, then you can run inside your Eclipse also. Otherwise, you have to build a jar here and then take it to the edge node and run it on the edge node.
Okay. Any data if we have to get, we have to depend on file systems only.
Yep.
Thank you, Shiva. Thank you very much. Enjoy your weekend.
Yeah.
Okay.
Any questions, Purushottam, Mohit, Madhavi, Kalpana, Gopi? Kalpana?
Yes, Shiva. Generally, how we are building the Spark applications in real time? Is it through Maven or is there any other?
We use Maven only. Okay. We use Maven, and we specify because all our developers are most familiar with Maven. They use Maven only. And at the same time, I'm not against SBT. SBT is also simple. The name itself is a simple build tool. It's even more simpler than Maven. But since this is a new build tool, people say that They may not be that addicted to the new one, right? So sometimes they might not use that. But SBT is also very, very, very simple. You can use either of them. That doesn't make any difference. Doesn't make any difference.
Okay. So, I mean, if there are any changes in the versions, then we need to change in the dependencies of pom.x.
Exactly.
Okay.
That's the only. If you want to point to all of a sudden, if you want to, you are building your application in Spark 1.5. So your latest version in your cluster is Spark 1.6. Your administrator has upgraded Spark version there. So, and if it has to work on that, if you want to compile against using the 1.6 packages or 2.0 packages, you can change just the version and rebuild your application. That is very seamless building. Like you don't even.
Okay, I got it, Shiva. Thanks.
Any questions, Mohit?
Shiva, this is Gopi.
Yes, Gopi.
Yeah, you have shown an example that the usage of Java in Scala.
Yep.
And even Scala usage in Java.
Correct.
Okay, if method is having a tuple written, okay, then will it just, if I use the same, can I use the same method in Java application? How can it will be supported?
Yeah, you can use the same time. You have to declare a corresponding bean class or a poso class in Java, and you have to capture that result. Your Scala will return a tuple. You have to catch that into a bean or poso in Java.
Okay.
Yeah. Good question. Like Madhavi. Madhavi, Mohit, Purushottam. Okay. Yeah, I mean, do you have any questions? I know you are there. I'm just checking. Like, yeah, we can meet on 8:30 a.m. in the morning again. It's for Madhavi. Okay, Madhavi and Gopi. Okay, thank you guys. Then if you guys don't have any questions, yeah, then let me wrap up the today's session. Thank you very much. Bye bye. Okay.